In this video, we'll talk about intervals in the specific context of major keys or scales. So, why is a major scale called a major scale? Well, I don't know exactly the reason why, but one good indication is by looking at the intervals that are formed between the tonic of any major scale and the other scale degrees. If you do that, and I have done that here with C major, what you have is a major second between C and D, or in other words, between scale degree 1 and scale degree 2. You have between 1 and 3 a major third, between 1 and 4 a perfect fourth, between 1 and 5 a perfect fifth, between 1 and 6 a major sixth, and between 1 and 7 a major seventh. Right? This octave here perhaps is self-evident, but it goes to show that all intervals formed between tonic and the other scale degrees are either major or perfect. Now, why are intervals called major, right? Why is that name chosen? I'm not quite sure, but I think there is this correlation here between a major scale and the intervals formed between the tonic of that major scale and all other scale degrees. Now, while I have done this here for C major, these intervals, these relationships are true for any major scale because the pattern of whole tones and semitones is always the same. The intervals follow suit. They will always be the same. Right? So any major scale, the intervals between scale degree 1 and the other scale degrees are either major or perfect. That is to say as well that intervals between any other scale degrees of a major scale are always the same for those same scale degrees in all other major scales. So I have provided a quick example here for you. Here we have two notes in D major, an ascending melodic interval, and we are departing from scale degree 3, which in D major is F sharp, to scale degree 5, which in D major is A. And that makes a minor third. So if our theory is correct, all intervals between scale degrees 3 and 5 in any major key will always be a minor third. And that is what happens. So I got another example here of a key or scale that is as distantly related to D major as possibly one could get. Maybe not as distant as possible, but pretty distant, which is A flat major. Once again, I got scale degree 3 in A flat major, C. Scale degree 5 is E flat. And according to theory, that does conform to the idea that we have a minor third here. Any major scale you get between 3 and 5, between scale degrees 3 and 5, you will always get a minor third. Right? You can see here in C major as well. Between E and G, you have E, F, G, 3-letter names, so that is a third. And if you count the semitones, you'll get to 3 semitones between those two notes, so that is a minor third as well. What gives a major scale its particular sound, right? You can just listen to it and know it's a major scale. Is, as we've said before, this idea of the pattern of whole tones and semitones, and in consequence of that, all of the intervals we get from calculating the distances between all scale degrees to all other scale degrees in that particular scale. Once we see what intervals are preferred or favored in a scale, we can get an idea of its, go further down in its DNA and understand why it sounds the way it sounds. Seconds. Here we have all of the possible seconds in a major scale. And once again, I've chosen C major because that is the key or scale that does not contain any accidentals. So I think it's easier to see those things here. But as you see these relationships being formed, for example, the interval between scale degrees 1 and 2 being a major second, that will be true once again for all other major scales. So what you have here is a major second between 1 and 2. Between 2 and 3, you have another major second. Between 3 and 4, E and F. Remember the piano keyboard? There's no black key in between them, so there's only one semitone of distance. This is a minor second. 4 and 5, major second. 5 and 6, major second. 6 and 7, major second. 7 and 1, closing here the octave, another minor second. So you'll see that the preference here is clearly for major seconds. We have 5 major seconds and only 2 minor seconds, right? That is relevant. This is synonymous pretty much to the idea of whole tone, semitone, etc., right? The whole tone, semitone pattern. But it's nice to see it as well in terms of sizes and qualities of specific intervals. And as we get down the line here with larger intervals, we're going to see that there's also a preference for some types of intervals and some qualities of intervals over others. So we always have 7 of each, right? We have 1, 2, 3, 4, 5, 6, 7 of each because there are 7 scale degrees. So we have 7 types of thirds, 7 types of fourth, etc. But it's nice to see what the qualities that are favored here. So if you're looking at thirds, we have 1 major third between 1 and 3, minor third between 2 and 4, another minor third between 3 and 5, another 2 major thirds, and then to close off 2 minor thirds. So it's pretty evenly split. We have 1, 2, 3 major thirds and 1, 2, 3, 4 minor thirds. Perhaps counterintuitive, you'd think that there would be more major thirds than minor thirds in any given major scale. But this is the layout of it, right? And as we get further into harmony, into triads, and into chords, we'll see really that even though there are more minor thirds in a major key than there are major thirds, the most important scale degrees, 1, 5, and 4, are the ones that have major thirds, right? So that is really relevant too, and will become more so as we get deeper into harmony. How about fourths? Just a quick glance at fourths reveals that all of them are perfect fourths except for the distance between scale degrees 4 and 7, an augmented fourth, right? This is relevant. Perfect fourths are the most numerous of any interval in a major scale that of a single kind, right? Of the same quality and size. And this augmented fourth is really important because it stands out from the perfect fourths. This is, in other words, as we've seen previously, the tritone, right? That very dissonant interval. So very interesting relationship. We start seeing why music has worked the way it has from looking at the inner workings, the intervals formed between scale degrees. And this list is more or less redundant. And why I say this is because here in this list we have the complete set of fifths, sixths, and sevenths of a major scale, but we can get to these by inverting these, right? So once we have done the work for seconds, thirds, and fourths, we have pretty much done the work for fifths, sixths, and sevenths. It's just that these are all inversions. These are all the idea of swapping the bottom note for the top note, etc. Right? So for example, here in seconds we have B to C, right, as that minor second. Here in sevenths we're going to have C to B, right? So everything is kind of the reverse of what was before. And likewise, since we had, for example, 6 perfect fourths and an augmented fourth previously, as we saw, here it turns out that we have 6 perfect fifths, as one would expect from inverting those perfect fourths, and 1 diminished fifth. Once again, there's only one of a kind here, which is the tritone, the inversion of that augmented fourth, right? Okay, I think this is all there is to say about intervals in any major scales. For our next video, we'll talk about intervals in minor keys or minor scales.